Hello students, Standard 8, Visualizing Solid Shapes. In the last session we will understand about the polyhedral family. We saw that in the solid shape when bases meet at edges meet at vertices, then they are known as polyhedron, like cube, cuboid, prism, etc. Prism and pyramid, they are the main two important members in the polyhedra family. You know that what is prism and what is a pyramid. In prism, the top and base are the congruent surfaces and other surfaces are parallelogram. And in pyramid have a base, and then base is a polygon, and the other surfaces are triangular, which meet at the common vertex. So we learn about the different number of faces, edges and vertices in different polyhedra. Now today we are going to learn about a important formula, that is Euler's formula, which shows the relation between the number of vertices, number of faces and number of edges of different polyhedron. So let us understand by writing the number of faces, vertices, edges and derive a relation between them. That is the Euler's formula. So here I made a table here. In table F stands for number of faces of the polyhedron. Then V stands for number of vertices. E stands for number of edges. So we will write down first F, V and E of each. Then last two columns we will check F plus V and E plus 2. And from that we will find out the relation which is known as Euler's formula. The first solid is cuboid. Cuboid is like a compass box. How many vertices? First faces. Faces we know that 1, 2, 3, 4, 5 and 6. So there are 6 faces in a cuboid. Vertices are the point at which, so 1, 2, 3, 4 and similarly 5, 6, 7 and 8. So there are 8 vertices in that. Now edges are the line segments. So here you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. There are 12 edges there. I hope you understand. Look here, 1, 2, 3, 4 and similarly at the bottom 1, 2, 3, 4, 8 and then 9, 10, 11 and 12. So there are 12 edges of that cuboid. The last two columns we will fill at the last. Now check the other triangular pyramid. Pyramid with triangular base. Base is triangle and the others meet at the top pyramid. So one base and another 3 sides. It means there are 4 faces. Triangular pyramid will have 4 faces. Vertices. Vertices are like points. So 1, 2, 3 at the bottom and 1 at the top. So there are 4 vertices in a triangular pyramid. And edges. Edges are 3 at the bottom and another 3 coming to the top. So 3 plus 3, there will be 6 edges there. Now another is the triangular prism. Triangular prism means it have 2 edge, the top and base are the same triangle, and then it is like that. So 2 triangular bases and another 3 sides. So 3 plus 2, 5 faces are there. Now vertices, you can see that 1, 2, 3 and 4, 5 and 6 vertices will be there. 3 and 3, 6 vertices. Now the edges, 2 triangular bases means 1, 2, 3, 4, 5, 6 and then 7, 8 and 9. So 9 are the number of edges here. Then pyramid with square base. Square base with the pyramid means one side, then from all the 4 sides the triangular are there. Means 4 plus 1, 5 faces are there. Vertices 4 at the bottom and 1 at the top. So 4 plus 1, 5. Now edges, 4 at the bottom and 4 coming to the top. So 4 plus 4, 8. Then last, prism with square base. Actually prism with square base is same like the cube. We already wrote down yesterday also. Cube means same as cuboid, means 6, 8 and 12. Because prism with square base is same like the cube. And therefore, now we will fill up the last 2 columns in each object. First one is cuboid 6 plus 8. If F plus V means 6 plus 8. What is 6 plus 8? 14. And E plus 2. 12 plus 2, that is also 14. So here in the last 2 columns answers are equal. Doesn't matter. The here number are different. Now for triangular pyramid, F plus V, 4 plus 4 is 8. And 6 plus 2 is also 8. Here 5 plus 6 is 11. 9 plus 2 is also 11. 5 plus 5 is 10. And 8 plus 2 is also 10. 6 plus 8 is 14. And 12 plus 2 is also 14. So here, what can we observe? What can we observe? We observe that in last 2 columns, for each solid, the answers are same. Means F plus V and E plus 2 value, you can see that 14, 14, 8, 8, 11, 11, 10, 10, 14 and 14. So from the last 2 columns, 2 columns of the table, we can observe that F plus V is equal to E plus 2 in for each of the solid shapes. So here F plus V equals E plus 2, or you can take E this side, then F plus V minus E is equal to 2, are called Euler's formula. So you can choose any of the relation. F plus V is equal to E plus 2, or F plus V minus E equals 2. Now, in the question, if any two of the F, V and E is given, any two from the number of faces, number of vertices and number of edges are given, then we can find the remaining value by using this Euler's formula. Or sometimes the question can be like that also. They give the all three F, V and E and ask you to verify the Euler's formula for this solid. So in this situation we have to put the LHS and RHS different values and then you find out the relation like this. Now we will start exercise 10.3. Question number 1. Can a polyhedron have for its faces first 3 triangles? Now, if you notice the polyhedron, all of them, you can see that they can have only minimum number of faces should be 4. So, only with the 3 triangles it is not possible. So, you can write down no as there are minimum 4 faces in a polyhedra. Second one is 4 triangles. Now, if you think about the pyramid with triangular base, if you see that pyramid with triangular base, so it has a triangle base and 3 triangle bases meet at the common vertex. So yes, a triangular prism has 4 triangles as its faces. Third one, a square and 4 triangles. Now if you think square is a base. So if it has 4 triangular surfaces to make a pyramid, then it is possible. So yes, a pyramid with square base has such type of faces. So when a square pyramid is that, means pyramid with square base, then from all the four sides, the four triangular surfaces goes up to meet a common vertex. So it has a square and four triangles as its base. So it is possible also. Now question number 2. Is it possible to have a polyhedron with any given number of faces? So now question is little twisted. Actually, if you think, then we can have any number of faces in a polyhedron. So it looks like that it is yes, but on one condition. It must have number of faces 4 or more than 4. Because if they ask, is a polyhedron of 3 faces available, 2 faces available, 1 face available? No. So we can write down, it is possible only the number of faces 4 or more than 4. Means if they ask about the polyhedron with 3 faces, we won't be able to find any polyhedron having only 3 or 2 faces. Question number 3. Which are prism among the following? Which are prisms among the following? Among the following. Now first one is a nail like this. A nail. We learn in the polyhedron that they cannot have any curved faces. But here a nail has a curved surface and a flat surface. So it is not prism as it has curved surface. Then second one is, it's like a pencil. Like that. You will see that a pencil with unsharpened pencil. Unsharpened pencil. So when the pencil is unsharpened, you will see that the top and the base will be the same hexagonal. Same base. And other surfaces are parallelogram. So it is a prism. It is a prism. Third one is a table weight like that. Now you can see that it is having the one common vertex. It is a pyramid, not a prism. It is a pyramid, not a prism. And the last one, a box. You can see that box will have same top and base. So it is a prism. It is a prism. So for prism, what you have to think is that top and base should be the same, and other are the parallelograms. So here we are going to finish the session and followed by PDF. Any confusion, there is comment section. Thank you very much.